written your observations, let's come to the analysis question. All right? Metals are supposed to be shiny when they're pure. You looked at calcium and magnesium. Were calcium and magnesium shiny?
No.
Okay. A lot of you are not paying attention. Remember, lab tests are open notebook tests. Is that right? And can you retake them?
Nope.
You cannot. So I need you to be really attentive as I go over the discussion. Yes, Jennifer. You should have these questions in the lab notebook and you should be writing answers down as I discuss them. Now, what I find is a lot of students just blindly, are you listening to me?
Yes, ma'am.
They are not thinking up here. They're not listening. What are they busy doing? Just copying down what the teacher is writing. What did you write? What did you write? Because they're not using their head at all. If you actually listen to what I'm saying, and if you understand it, can you write it in your own words?
Basically.
Most of the time, yes. It's not that hard. Alright? So I really need your head to be working as I'm discussing. So here is the first question. Was calcium and magnesium shiny?
No.
No. The question is, why are they not shiny?
They oxidize in air.
Very good. So metals react with oxygen in air and oxidize.
Wait, so, I'm sorry.
Yes.
Are we allowed to use this during the test or not?
You're supposed to have it in your lab notebook. Did Ms. McGrain last class ask you to copy the data table into your lab notebook?
Not to our reckoning, no.
What?
I don't remember it. I remember copying the...
I never told you that.
I heard this. Copy the data table. I didn't hear copy down the questions.
Casey's right. She said to copy the data table and not the questions. We didn't have time for it. Is that right? You should be having the questions down as well. Everything should go into your lab notebook.
What else we don't have?
Ms. McGrain, you should have a lab notebook.
No, I had it, but I forgot it.
Okay. I think as I'm aging, I'm getting more and more lenient with my kids. All right? There used to be years when I would pull out and throw it into the trash can and say, too bad, you don't have your lab notebook. Okay? Maybe for this lab, I'll let you use the worksheet. But someone make it a point to enter this back into your lab notebook. The reason why I do it is, I give an end of the year lab assessment, and I will pull from all over. If you don't have your notebook organized, how are you going to do it?
You're going to be screwed, basically.
Okay? All right. So metals, so we are saying it's not shiny because the metals react with the oxygen in the air and oxidize, correct? The layer of oxide on the metal is not shiny. Does that make sense? That's why the metals were not shiny as we looked at them. Is that clear? Now, did anybody touch the test tube when you added water to calcium? How did it feel? If you felt it was hot, is it an exo or an endothermic reaction? It is an exothermic reaction. As the test tube felt hot to touch. So we did 3 metals. We did calcium, magnesium, and aluminum. Which do you think was the least reactive?
AL.
Aluminum is the least reactive. Which was more reactive than aluminum? Magnesium. Which was the most reactive one? Calcium. Alright? So aluminum, magnesium, calcium. How would you define a metal's reactivity? What do metals like to do? What do you mean by react?
Usually a metal loses electrons.
Losing of electrons, alright? The ability of metals to lose electrons is defined as their reactivity. So now we compared 2 metals down the group. We had magnesium and calcium. They were in which group? They were in group 2, correct? What happens to reactivity of metals as you go down a group? It increases. The reactivity of metals increases as you move down. Use observations to support. Calcium was more reactive than magnesium. Calcium was more reactive than magnesium. Explain why you think this trend happens using your knowledge of atomic radius and ionization energy. The atomic radius increases and ionization energy decreases, making the metal more reactive, making metals more reactive down the group, right? More reactive down the group. Do we understand this? Can you write it in your own words? I'm squeezing it all in. Do you think you can rewrite it in your own words? Radius increases ionization energy, decreases reactivity, increases. Do we know this? Okay.
What is that symbol for atomic radius? Is that IE?
And ionization energy. Alright. We compared 2 metals across a period. Magnesium and aluminum were in period 3, correct? Were they both in period 3?
Yes, ma'am.
What happens to reactivity of metals as you move across? It decreases. So reactivity of metals decreases across a periodic table. Use your observations from the lab to support your answer. Aluminum was less reactive than magnesium. Aluminum was less reactive than magnesium. Based on this trend, what do you think happens to the atomic radius and ionization energy of atoms as you move across a periodic table? The radius decreases and ionization energy increases, making the metal less reactive. Do we understand this? Right? Do we follow this? Okay. Let's move on. We are now going to get into non-metals. All right? Before I go, I'm going to go back for a minute. All right? I need you to draw a periodic table on the bottom. And which side is your metals? These are the metals. And what do metals like to do? Lose electrons. And what happens to reactivity as you go down? What happens to reactivity as you go down? Increases. And what happens to reactivity as you go across? It decreases. Right? If I ask you a different example, which will be a more reactive metal? Potassium or copper? They're both in period 4. Potassium or copper?
Which will be less or more?
Which will be more reactive? Potassium or copper? Potassium. Which will be the more reactive metal? Copper or gold?
Gold.
More reactive.
Wait, is gold AU?
AU. Well, that is interesting because it follows the F block. Let's do another one. Which will be more reactive? Calcium or radium? Which will be more reactive?
Radium.
Radium will be more reactive. Do you understand this?
Yeah.
Okay. Let's move to non-metals now. Non-metals are on the other side of your...
Can we copy down the diagram?
Yes. Make sure you know the pattern in a periodic table. All right?
Okay, I got it.
On the next page, no, we'll look at a video and hopefully you'll understand from there. All right. So let's see. For the non-metals, we are now in the non-metal side. What do non-metals want to do?
Gain electrons.
Non-metals want to gain electrons. And these are your non-metals. So what did we say about metals? What happens to the reactivity as you go down? What happens to reactivity as you go down for metals? For metals, it increases. What do you think will happen to non-metals? It's the opposite.
So it decreases.
It decreases. It's going to decrease going down. For metals, what is the pattern going across? Decreases. What do you think will happen to non-metals as you go across? As you go across, it increases. Which is the most reactive non-metal on the periodic table? Fluorine is the most reactive non-metal on the periodic table. Which is the most reactive metal on the periodic table? Francium is the most reactive metal on the periodic table. All right?
Alkali metal too.
Huh?
It's alkali metal too.
It's an alkali metal too. Now,
Is it?
there are things I need you to know before I actually show this video to you. All right? Now, we have chlorine. Okay, this is not writing well, so I'm going to write on this side. We have chlorine, bromine, iodine. Is that right? If I write it as Cl minus, it becomes chloride, IDE. If it's Cl minus, how do I write it as? Chloride. But if I write it as Cl2, that is chlorine. If I write Br minus, what is that? Bromide. Br2 is what? Bromine. I minus is iodide and I2 is iodine. Now, the chlorides, the bromides and the iodides are water soluble. They are water soluble.
Like water.
They dissolve in water because they are ions. Do you understand? Whereas the chlorine, the bromine and the iodine are non-polar and not soluble. Not soluble. Alright? So what did we say happens to reactivity as you go down? Reactivity becomes lesser and lesser. Is that right? So chlorine is more reactive than bromine, is more reactive than iodine. Now I'm going to show you a small video clip. Okay? And watch it.
Allergen.
So they're soluble ions. They're water soluble. They're minus ions. Okay? Chlorine. This is aqueous because they cannot try to dissolve it in water. Okay? These elements, cyclohexane is non-polar. Okay? See, it's non-polar, so it's non-contact with water. You see that? Now you shake it. Okay, we need to stop here. So this is the end result of the reaction that happened. Okay? And we need to understand this reaction in terms of reactivity of nonmetals. So we have chlorine, bromine, and iodine. Is that right? Chlorine is most reactive, iodine is least reactive. If you add chlorine water, alright, chlorine water is colorless, alright, but when it reacts with bromine, chlorine is able to kick bromine out. It reacts, and so that is bromine collected there in hexane, Br2. When it's added to iodine water, it kicks the iodine out because it's more reactive. And that is iodine collected here. Now this orange is the color of bromine water. Bromine is not able to replace chlorine. Bromine in bromine water is going to do nothing, but it kicks the iodine out. Did the color change here? Do you see this? Here, this is the color of iodine. So no reaction has happened. Okay? Let me actually teach this to you in a way that I taught my other class so that you understand. Alright? Say I have Na is my metal or my male. Think of it like that. Alright? Chlorine is my female or my non-metal. Plus, I'm trying to add bromine water to it. This is the second reaction. Do you understand? I'm adding bromine water to chlorine here. Alright? This is more reactive. Is that right? And this is less reactive. Alright? Speaking in teenage language or talking sexually, if this is the male and this is the female, she's the more active female. And bromine is the less active female. Do you think this male is going to dump this female for this other female? No, reaction is not going to happen. No reaction. No reaction.
Personality, okay?
Alright? But if you have the opposite, if you have NaBr plus, let's say you have NaBr and you are adding chlorine water to it. Alright? Do you think chlorine, sodium will dump bromine for chlorine? Yes, because it's the more active non-metal. Do you see that? So this reaction, what will happen is Na will now start going out with chlorine and bromine gets dumped. You understand it? The more active the non-metal, it will take part in bond formation. Does that make sense? So this reaction is actually happening here. You're adding chlorine water to your solution. What gets kicked out? Bromine gets kicked out. Chlorine enters. What gets kicked out? Iodine gets kicked out. Alright? Okay? In this case, bromine does nothing to chlorine. Alright? So it's going to stay. Bromine with bromine, nothing. Now it's the more active non-metal kicking out bromine and the color changed. Do you see that? There is no reaction here. Is that right? Yes, absolutely. That's the original color of iodine. Do you see that? Wherever the color is changing, that's where from here to here, the color is changed. Is that right? These two are the same color. Here it's changed. They're the same here, no reaction. Do you understand? Okay, let's answer the post-lab questions now. Let's escape. Let me get rid of this. Okay? So these are the test tubes that you need to draw. We are not going to do it elaborately. Instead, we'll answer questions. In a reaction where bromine was capable of replacing the other, was bromine able to replace chlorine? But if bromine, here was iodine, do you think this reaction will happen? Do you think this reaction will happen? Yes, it's going to happen. So it will form sodium bromide plus iodine. Is that right? So this will happen. The question is, in a reaction where bromine was capable of replacing the other halide ion, which halide ion was bromine capable of replacing? Iodine. Was iodine above or below bromine? It is below bromine on the periodic table, correct? Is iodine below bromine? Alright. Which was it unable to replace? It was unable to replace chlorine. Was chlorine above or below bromine? It was above bromine. Now, halogens are more reactive than the halogens below them. Is that right? Those that are above are more reactive than those that are below them. Do you think chlorine can replace iodine? Yes. Do you think chlorine can replace fluorine? Can chlorine replace fluorine? No. Do we understand reactivity of nonmetals? Do you understand it? Alright? We're going to stop now. We're going to take the last quiz. What is it, Julian?
Well, Ms.Geeta's letting you
Use the worksheet this time. Okay? Someone ask for that permission.
Thank you.
I don't have the last information.
I'm sorry, yeah. Okay.